right, so you should have this. If I've seen you in person, you should have this in your packet. If not, it is linked in Google Classroom, and I want you guys to take a second and basically do the same thing with the cosine function that we did with the sine function originally, and that is fill in this table exactly like the theta value, exactly like we had for the sine graph when we first did it. Here's what we're going to be graphing, and here you're going to put in what the cosine is at each of these angles. So both as you go around the positive direction and as you go the negative direction, then you're going to plot them. You're going to scale the axis just like we did before, and you're going to scale this just like we did for sine, and then you're going to plot cosine, and then you're going to look at it and see what it has in common and what it doesn't have in common. So please pause the video if you haven't done so already and complete this portion of the graph. Okay, hopefully you took care of that, and this is what it should have looked like. These are your coordinates in terms of your output values when you take the cosine of each of these angles, and I kind of put the coordinates as we go around. Remember, cosine are the x-coordinates on the unit circle, and then if I plotted them, this is the shape of the cosine graph. So take a close look. Notice there are some differences and similarities with the sine graph, and so that's what we're going to talk about next. But first off, this graph should match yours. If not, pause it and go back and see why. This is the general cosine graph, and we're going to talk about the key position. Again, I'm going to plot that quickly just in one session here, one period of the cosine graph, where it looks like instead of the above graph, which had a couple periods of it. Notice that for us, the very first point, the first position with cosine is right here. It is no longer on the midline like it was with sine. It's now at the very top. So the first position of cosine is that it starts at the max, then it goes to the midline, and after it goes to the midline, it goes to the min. So the pattern is the same as sine, goes to the midline in terms of this max, midline, min, midline, and then I end up at the max. It's just out of order from what it was with the sine. The domain of cosine is just like it was with sine. Negative infinity to infinity. The range, before I transform it, it goes up to 1 and down to -1, so the range is still -1 to 1. And the period for cosine, notice I complete a full cycle from top all the way back to top in the span of 2 pi. So in thinking about the things that are the same between the two graphs, the domain is the same, the range is the same, the period is the same, the overall general shape in general, it just looks kind of like this wave. That didn't change, but the differences happen to be kind of where it starts. And so if we're in person, you guys might have come up with some different topics for this. The starting position is different. The other class that I had in person came up with this idea, and I didn't really think about it that way before, but that's what this key x value, the first key x value, is in a different starting position than the sine one, but the pattern is the same. It just starts at a different point in the pattern. So the pattern is the same. So I'm going to walk you through graphing one cosine, and then you're going to practice one, and we're going to go from there. So again, remember this is A. These are the same values that we had with sine, A, B. Then there's usually a C in here and a plus or minus D at the end, but notice there is nothing in those two positions, so I only have values for A and B. I'm going to write them in order just so we kind of remember them. So amplitude is A, and for us that's 3. And then we're going to just ask ourselves every time, is there a reflection? Only if it's negative, so no reflection. B is your impacts your period. It doesn't equal the period, but remember the period is equal to 2 pi over B. So B is what impacts your period. So for us in this problem, the period is 2 pi divided by 2, which is pi. So the B value comes into play to help my period. And then my key intervals are always whatever my period is divided by 4. So pi divided by 4 are my key intervals. And then phase shift would be C, and there is no phase shift on this one. And my midline shift is D, and there is no midline shift on this either. So what I'm going to do first is I'm going to come up to this. Because there's no reflection and there's no midline shift, I can take care of this amplitude because I know I'm going to go up to 3 and I'm going to go down to -3. My phase shift, there is no phase shift, so I know I'm going to start right here on the y-axis. My period is pi, so I'm going to break this into 1, 2, 3, 4 pieces to get my full period in, and that's what this is telling me, is each of these increments now is a pi over 4. So that's pi over 4. Another pi over 4 puts me at pi over 2. Then I'm at 3 pi over 4. And I could do 4 more. They should be even, and they're not. That's too bad on my part. 1, 2, 3, 4 would put me at negative pi. 1, 2, 3, 4 would put me at negative 2 pi. And then I can go with my pattern. And the pattern is at each of these increments, I start at the max. So there I am. Then I go to midline. So there is the midline at my next increment. Then I go to the min. So at the next increment, I'm down at the bottom. Then I go back to mid, back to midline, and then I end at the max. So that's the cosine pattern. I'm up here, and again, this is kind of scrunched, but that's because we had a period shift adjustment. And so if I were to do it again, I would come down there. I could keep going on this side if I wanted to. I'm not being particularly precise in terms of hitting my 3 and -3, especially over here, but you can kind of see the pattern. All right, so that's kind of taking each of these same ABCD values that we did with sine into consideration for cosine. So this is practice number 2, right here. And I would like you to pause the video and try this one yourself, and then we'll take a look at it, see how you did afterwards. So please pause the video for a few seconds and try this one. All right, so I have all of the key values written over here. The amplitude is 1, but there is a reflection because it's negative. There is no number here in front of the x, so the period is still 2 pi, and our key intervals are pi over 2, which is what we were dealing with before anyway. That's our regular intervals. So I can just kind of sketch those on here the way we saw most of ours without having to worry about doing any kind of weird stuff at all. So 1, 2, 3, 4, negative pi, 1, 2, 3, 4, negative 2 pi. That's kind of how we were gridding them all out before. So I don't have to worry about anything weird with that. I do have a phase shift. I have to go pi, and this is the land of opposites, so I have to go to the left pi. So I have to go this way, pi. And I also have a midline shift down 1. So that's the first thing I'm going to graph is this. That's number 1. So I'm going to go down 1. I'm going to put a little mark on there because that helps me realize that my max is going to be up here and my min is going to be at -2. My max is at 0, my min's at -2. So that's taken care of. I've already got this kind of sketched out. I do have a reflection. This is going to be kind of weird. I've got that taken care of. Now I'm going to phase shift left pi. So if I usually, for cosine, you would start at the max right here on the y-axis. But I phase shift left pi, so now I have to start here at -pi because I went left pi. But a reflection boots you down on the exact opposite side. So the reflection is going to be, instead of starting at a max, that reflection means I'm going to do it the opposite. I'm going to start at a min. So instead of starting there, I have to start down here. And then the pattern goes midline, max, midline, min. So it's the exact opposite of what it is when it's not a reflection. And then it would keep going, continuing exactly like we just did. I'd come up through there, and I'd be up at the top, etc. Same here. I'd go boom-a-doom. So that is one thing, is it changes my start. I would start at the min instead of the max, and I'd also start left pi. All right, so that is graphing cosine. The next couple minutes, we're going to do this. I'm going to kind of show you how to go about this, and then you're going to do one yourself. So this is a graph, and we're going to write an equation, a sine equation for this. So key step number 1 is to do this first, the midline. I'm going to draw it. You have to find where it is, and it's a visual thing. So my midline is at y equals 1, which means I know I have a plus 1 at the end. That was that value that went in the place where d was in that equation. Remember, we had a sine b x minus c plus d. That's a b. So I'm kind of filling in what these are, but this allows me to see very quickly and clearly that this is my amplitude, and it's the same to maxes and mins, and that's a distance of 2. So my amplitude's 2. If I'm graphing sine, I want to start right here at the origin, which I do, and I'm going the right direction. So there's no reflection or anything weird in that. The period, I have to look at this. I don't know. I start here at the origin. I go up down, and I'm back to the origin here, and that is 2 pi. So my period's 2 pi, which means b is going to be 2 pi divided by the period. These just flip-flop going backwards. And if the period's 2 pi, boop, that 2 pi divided by 2 pi is 1. So I don't have a b value. It's just going to be, well, I do, it's 1. So I can start to kind of fill this equation in now. I've got an amplitude of 2. I have sine, a b is 1, so I'm not going to write it. And I don't need to write it there. And then I'm going to look, is there a phase shift for sine? Did I leave my original normal starting point? And I didn't. So there is no phase shift for sine, so I don't really have to worry about the c value at all. And then I know I have a plus 1 on the outside. Voila, I'm done. Now the tricky part is doing cosine. So cosine is starts at the top. It doesn't start at the midline. So I'm going to erase that little red dot right there. I'm going to get rid of these two so we can kind of play this game. So the first thing to keep in mind when you're doing a cosine versus a sine graph, the values for A and B and D aren't going to change. The midline is identically the same. So I know my cosine is still going to be a plus 1. The amplitude is still 2. It's still the same distance from the midline. So when I graph this, it's still going to be a 2. I just have to put a cosine in here. What's going to change is, and again, the period doesn't change. This graph the period doesn't change when I switch from sine to cosine. What changed is my starting point. Cosine starts at the top. So there's where my cosine start would be. Notice that is shifted over to the right. It's usually on the y-axis, and this is how far it's shifted. It shifted pi over 2, and it shifted pi over 2 to the right. So in here, I do land of opposites, and I put x minus pi over 2. And these two graphs, if you typed them in your calculator, would look identical to each other, and it would look just like this. So you are going to take a second and try number 2. You're going to try it for sine, and then you're going to try it for cosine. But try it for sine completely first. We'll check it, then we'll do cosine. So I'm going to pause, you're going to pause, and you're going to try it. All right, so once again, I first did the midline. It's at -2. That's down 2. From the midline to max and min, that's amplitude of 1. This is definitely more waves in it, so you notice that one cycle is actually done right here by the time I get to pi. So my period is pi, so b is 2 pi divided by the period, and so that equals 2, so my b value is 2. That makes its way right here. Amplitude is 1, I don't need to write it. There is no phase shift. Sine starts at the midline, and it does right there. And I go down to for my d value or my midline shift. So if I was going to do cosine, once again, I do have a bit of a phase line. A phase shift for cosine. If I don't have one for sine and I want to write a cosine, I do for cosine. So again, notice I want to start right there. That looks like it happens, I'm going to go like this far to the right to get to the max, because cosine starts at the max. And that looks like it's about halfway between 0 and pi over 2. So I've right pi over 4. And so my cosine equation, again, amplitude doesn't change. Oops, I almost did it. The only thing that changes is that as a cosine graph, the b is still 2. That's got to sit outside of my parentheses. And it's a right pi over 4, so I put x minus pi over 4. Close it, and it's still down 2. And that's my cosine equation. Again, the only thing that changed was the phase shift. All right, that is it. I hope you enjoyed. And there's a third one. You can try it if you would like, and I will post the answer for you in a moment. Well, I'll do it in a second. You pause the video, and then it'll be right there. All right, so there's a lot going on here. First off, I'm going to point out that the period, if I just pick a point, this is like at the very top, I don't reach the top again till way over here. So that's from -5 pi over 4 all the way to 11 pi over 4. So that span is actually a span of 16 pi over 4 or 4 pi. The midline's at -1. The amplitude is 2, goes 2 to both directions. And if I find a starting point for sine, which is at the midline, that's right here. That's a shift to the left, pi over 4. And notice it goes down, which means it would have to have a negative value in front of it. So my equation would be -2 sine 1/2 outside of the parentheses x plus pi over 4. It's the land of opposites, so left is a plus, and then down 1 is -1. And if I think of cosine, the cosine starting point is right here, which is a shift 5 pi over 4 to the left, and that's at where it's supposed to be at the max. So I don't have a reflection, so it'd be 2 cosine 1/2 x plus 5 pi over 4 -1. So that one is tricky. There's a lot going on in there, but there you go. Have a great day.